Alright, so this video is going to be on graphing sine functions, and it's actually my third video. So if you want to go to my channel and check out the first two, you can. They were on amplitude changes and vertical shifts, and now I'm going to talk about period changes. So what I'm going to first do is I'm going to first quickly get a sketch of sine of x onto my coordinate plane. That should help me out a little bit. And so I'm going to get this kind of going here. You would have a normal sine graph is going to go from 0 to 2 pi, so I'm going to just kind of label my axes. Pi halves, pi, 3 pi halves, and 2 pi. So I'm going to label my axes. In a normal sine graph, I'll kind of just go by 2's here so that it maybe looks not so smushed. But it's going to start in the middle, and then it's going to go up the amplitude, down, down, and then back up. So here's a normal sine graph. And if you want to continue it on, you can, but I'm going to keep just one period there just so that it kind of makes sense here. When we're talking about period changes, we're really talking about horizontal shrinks. So the period's going to get smaller. So you'd have y equals, say, sine of 2x. And we're talking about horizontal stretches. And a horizontal stretch would be when the period gets bigger or longer. So y equals sine of, let's go with 1/2 x. Okay, and so when you have horizontal shrinks and stretches, you're looking at the inside of the function. And so when I look at this 2 on the inside, I don't actually want to multiply the period by 2. I actually want to do the reciprocal. So I'm going to take 2 pi and I'm going to actually multiply it by 1/2. So 1/2 times 2 pi would just be pi. So the period of this function, sine of 2x, is actually only pi. So what we're saying here is that this tells us the period. So the graph is still going to start at 0, right? But then it would end one period only at pi, not at 2 pi anymore. So you would have one function. If you take a look at the graph, it would be here at 0, but then it would go up to 1, down, down, and then back up again. So your period is shorter, and therefore the graph is kind of shrunk in, if you will. And from 0 to 2 pi, you would be able to get actually 2 full periods in, because the period is half as much since you have this horizontal shrink. Okay, and with a horizontal stretch, you would kind of take the same approach. The value on the inside is less than 1, so you're going to multiply by the reciprocal. So 2 times 2 pi would be 4 pi. So what we're saying here is that the graph would start at 0 and it would end at 4 pi. Meaning that if you think about it, halfway, 2 pi, only half the graph would get covered from 0 to 2 pi, but then you would need 2 pi to 4 pi would be the other half. So I'll just draw half of it on this graph paper. So you would still start at 0, 0, but then it would go up the amplitude, and it would be at pi, and then down, right? And then it would have to go down again, and then up out here. And so you would have your one sine curve, but it would go from 0 to 4 pi, so 4 pi would be way out there. And so the graph got longer, so it was stretched out that period. And so period changes are not that hard to understand, but sometimes they can be a little tough to graph. And so finding your x values and making sure they're in the right spot. But that's what a period change is. It's really a horizontal shrink, okay, if the b value is greater than 1, or it's a horizontal stretch if the b value is less than 1. So quick recap of the graphing form of what we got here. So this d value, if you watch my first 2 videos, you would know that this talks to you about the vertical shift, right? The a value talks to you about amplitude, and it talks to you about reflections over the x-axis. And then the last thing would be is this b value, the coefficient of the x, and I've written it factored, and I'll talk about why in my last video, video number 4, but the b value is going to do our period change. So let's kind of talk about what could be a formula that we could create. So period change could be created as 2 pi is the normal period, but then to figure out the new period, you would divide it by the b value. So rather than multiply by the b value, we divide it by the b value, which will achieve the multiplying by the reciprocal, essentially. And so that's going to be what we kind of practice in the next 2 or 3 examples. All right, so here we go. So we're going to graph this function, f of x equals -2 sine of 1/2 x. All right, so we're going to break it down again, right? So with this breakdown, you should ask yourself, what's the amplitude? What's the period? And then do we have any shifts or anything? But it doesn't look like we do, so we'll just go with amplitude and period. So the amplitude is going to be 2, but it's negative, so we know we're going to want to reflect this at some point. And then to figure out the period, we're going to do 2 pi divided by 1/2, the b value. This is our b value, the 1/2. It's the coefficient of the x. And to figure out the new period, do 2 pi divided by 1/2. When you divide by 1/2, you'll multiply by 2, and you should get 4 pi. So that's our new period. So remember, sine and cosine both start at 0. Their start is at the x value of 0, unless there is a horizontal shift. And there is no horizontal shift here. And so we're then going to say, okay, where would the graph end, or the one period, where would it end? So it's going to start at 0, and then you would have to add 4 pi to 0 to figure out where it's going to end, so it'll end at 4 pi. And then the last thing you might want to do is figure out what are the notches in between. Remember, there should be 3 points in the middle of those two, and they should be equidistant. So there's a couple ways that you can figure this out. You could figure out the midpoint between 0 and 4 pi, which would be 2 pi. And then you could figure out the midpoint between 0 and 2 pi, which is pi. And you can start noticing that they're going by pi's, pi, 2 pi, which would mean this is 3 pi, and then 4 pi. Another way to think about, okay, what would the notches actually go by, right? How could I figure out that they're spaced apart by pi? Is take the period and divide it by 4. Because if you notice, there's 4 equal parts here, as I kind of highlight it. There's 4 equal parts to a sine graph or a cosine graph. And so if you multiply the period by 1/4, you'll figure out what they're spaced out by. But nonetheless, we have our first period. We know it goes from 0 to 4 pi, so I'm going to start graphing. I'm going to label my axes. So here we go, 2, 3, 4. And so this is 0, this is pi, 2 pi, 3 pi, 4 pi. And we're going to make 2 periods, and we can just go this direction as well. And so we'll have -4 pi, -3 pi, -2 pi, and -pi. Alright, so there we go. And it's -2 for the amplitude. So the graph will start still at 0, 0 since it's sine. We'll start at 0, 0, but then instead of going up 2, right, the amplitude will go down 2. So let's put our graph together. So it'll go down 2, then up, then up, and then down. Keep the pattern going. Whoops, didn't do that right. It's all good. Up 2, down 2, and then down 2, and back up. Okay, and there's our sine graph with the period change. And it's going to be really important that you label your axes so that people can see how this has changed. Because even though it may look like the same sine graph, when you put the x-axis here, now people are seeing, okay, one sine curve isn't going from 0 to 2 pi, one sine curve is actually going from 0 to 4 pi. So labeling your axes becomes critical, and then it allows people to read kind of what's happening in the graph. All right, let's do another one. So now we've got the graph of this function. We're going to break it down. We're going to ask, what's the amplitude? What's the period? And if you would like to try and do this one, you can hit pause and then check your answer with me and watch me work through it. So feel free to hit pause and do that. But the amplitude is going to be 3. 2 pi divided by 4 is going to tell me the period. So that would be pi over 2. So it's getting shorter, right? So it's a horizontal shrink. And what I like to do off to the side is just figure out where it's going to start and end. So starting point is going to still be at 0, and then it's going to end, if I add the period, that'd be pi halves. And so if I want to figure out what they're going by, right, if we start thinking about what's the notches, what are the notches going by, we could take this guy and multiply by 1/4, which would be pi eighths. And so this would go 0 to pi eighths, and then 2/8 would be 1/4. 3/8, that doesn't reduce. And then 4/8 is 1/2. And so that's where it'll start and end. It's from 0 to pi halves. And so we can then plot those points. 1, 2, 4. And we could do another one. And I like to go to the left with someone's asking for 2 periods. I'd like to go to the left. And the reason I go to the left, especially if 0 is in the middle, is because then it's just a reflection over. And you already know the x values are just the negative versions of these. So this would be negative pi halves, negative 3 pi eighths, negative pi fourths, negative pi eighths. You know that's 0, pi eighths, pi fourths. Okay, and then sine starts at 0, 0. And we'll just say it's the boxes that go by 1. And so you're going to go up the amplitude, down the amplitude, and then back up. Follow that same pattern. And there we have it. Oh wow, that was my best graph I've ever done in my life. Alright, so you can figure out domain and range and do all that, but hopefully it makes sense, right? If you look at this, it's only getting one sine curve from 0, right, here to pi halves. So maybe somebody could ask you a question is, how many sine curves would fit in from 0 to 2 pi? And you would say 4, right there. And you could say 4 of them would fit. Somebody might say, how many sine curves would fit in from 0 to 8 pi? And you could figure that out and say maybe something like 16. Okay, I've got one more. It's kind of weird, but it's not too terrible. It introduces some kind of neat things, makes things nicer, so I think you'll like it. So here we go. What's the amplitude? Everybody in the room would say 2, but you're probably going to need to do a reflection. Then the next thing would be the period, which we have that formula, 2 pi divided by pi. And notice the pi's cancel out, so that means the period's 2. That's weird. Or is it? Nope, it's not. Alright, and then you'd have the vertical shift. Okay, and the vertical shift is up 3 units. So let's figure out where it starts. Right, it's going to start at 0. And where's this going to end, right? The first period, where's it going to end? It's going to end at 2. And so those are just like literally the units. So on the x-axis, it's going to start at 0 and end at 2, but you know you need these 3 equidistant points also in the middle. And so in the middle of 0 and 2, that's pretty easy. 1, and in between that is 1/2, and 3/2. So actually when pi is the coefficient, it's kind of nice. It takes out the pi in the period, and it kind of makes your x-axis just back to a normal x-axis, which is kind of sweet when you're having to graph these things. So we're going to go with so that's 0. We'll call this 1/2. We'll call this guy 1, 3/2, and 2. All right, and so we're shifted up 3. So I'm going to draw a dotted line. That's my midline, shifted up 3. And so we know that sine starts at the middle. And then you're going to reflect it in the amplitudes too. So, boom, boom. There you have it. And so there's one sine curve from 0 to 2. And we can make a second one either to the left or right, however we feel. Okay? And that's how you deal with period changes. Hopefully that makes sense and everything's good. All right, have a great day.